Achari? Achari?
Sir. Sir.
Can you see the board? Can you see the board?
Yes, sir. It is visible. Yes, sir.
Okay. So today our topic of discussion is comparison among analog modulation schemes. And also, if time permits, let me start the noise in PCM system also. Okay. A little bit we discussed in the third unit. Okay. But anyway, let me start from the beginning in case of PCM. Okay. So anyway, in the last class, we were disconnected when I was deriving the last step of the equation. Okay, last step of the noise performance of FM system, isn't it? So this is what we are deriving in the last class. Okay, that is about noise power, output noise power. Okay, so the output noise power Pn not equal to integral of output noise power spectral density over passband of the modulating signal or message signal. Okay, and the message signal spectrum is, noise spectrum is symmetric, so we can integrate over only half of the bandwidth. By after that we can double it. So this is what we get. So after substituting the values and simplifying this, we can get 2 times eta by AC square, and this W is can be written as 2 pi f whole square. So I can write this as 4 pi square integral 0 to W 0 to W f square df. Now, so it is 2 into 4, 8 pi square eta by AC square. Okay. And after integrating this and substituting the value of W, what do you get? You get W cubed. Now let us find out the output SNR. So output SNR is simply equal to output signal power to output noise power. How much is the output signal power? We know, already derived it, but anyway, let me write here directly. It is equal to KF square into PM, P sub M. P sub M means here power of the modulating or message signal, and divided by this one. Okay, so when you divide this, 8 pi square eta W square W cubed into AC square into 3. Okay, now I can somebody's mom, you better all of you better put your mics in mute. Huh? Whenever if you want to raise any doubt, then only you unmute and ask me. Okay, so here we can write this in simple form as 3. See, I'm taking K F pi. This is 2 pi W whole square, and I'm writing this is a PM, and AC square by 2 whole square means 4. Remaining, there's a factor 2, so I can write it as 2 into eta W. And AC square by 2. What is it, AC square by 2? AC is the amplitude of a FM signal. So the power of an FM signal is simply equal to amplitude square by 2 because it is a sinusoid. The power depends only on the magnitude of sinusoid rather than its phase. So I can write this finally as 3 into AF by 2 pi W whole square into PM, and AC square B is called input signal power PSI. See, in many textbooks it is written as a SI, something like that. Okay, I mean bigger, I mean uppercase letter is used for signal S. It is eta W. Okay, and input signal power to eta W ratio is a standard form. Okay, we take this is a what do you call a factor of comparison among different modulation schemes. Okay, so this is how we can get a output S now as this. Okay, now so with this, noise performance of a FM system is over. So I think with this we covered the noise performance, or otherwise calculating output SNR for all types of analog communication systems like AM, FM. AM means all types of AMs. Okay, that is AM, standard AM, DSBC, SSB, and finally FM. Okay, now before to proceed any further to find out output SNR of PCM system, let us compare briefly based on noise performance. Okay, let's compare all the analog communication systems. Okay, so for that, let me take a simple problem. Okay, so this is the problem. Okay, so what is the problem says? There is an audio signal which is having a bandwidth of 10 kilohertz. It is supposed to be transmitted by using all these analog modulation schemes like AM, DSBSC, and SSB through a channel having an attenuation factor of 50 dB and a noise power spectral density equal to 10 power minus 10 watts per hertz. Okay. Now what we need to do is we need to determine the transmission bandwidth as well as transmitter power for each and every case of analog modulation scheme. In order to deliver deliver the message signal at the output of receiver with the signal to noise ratio of 50 dB, isn't it? Now let us proceed how to solve this. First we find out the bandwidth. We know the equation for the bandwidth for each and every modulation method or system or scheme. Okay, for AM, it is 2 times of message signal bandwidth, that is 2 into how much is the message signal bandwidth? Message signal bandwidth is, okay, so you see message signal bandwidth is 10 kilohertz. So it is equal to 10K. So equal to how much? 20 kilohertz is the AM signal bandwidth. Okay. Then DSBSC, for DSBSC also the same expression, 2 times of a message signal bandwidth, 2 into 10 into K equal to 20 kilohertz. Okay. Now What about SSB? For SSB, it is simply equal to the bandwidth of message signal. Okay, so it is equal to how much? Only 10 kilohertz. Yeah. So this is recording bandwidth. So that means if you want to transmit an audio signal whose bandwidth is 10 kilohertz, in case of AM, we need a transmission bandwidth of 20 kilohertz. In case of DSBs also, we need a 20 kilohertz. But whereas in SSB, we need only 10 kilohertz bandwidth. Okay. Now let us see the case of power transmitter power. Okay. So for that, we consider DSB, SC, as well as SSB. Okay. In these two cases, what is the expression for output SNR? Output SNR equal to input signal power, that is signal power at the input of the receiver divided by eta double. This is the expression for output SNR in both cases, DSB-SC and SSB. Okay. And this is equal to how much in our problem? The problem, it has been given as 50 dB. That means we need to deliver the signal at the output of receiver with output SNR equal to 50 dB. Okay. So 50 dB equal to how much? 50 dB numerically equal to how much? So we can now find out 50 dB equal to 10 log power. Okay. The ratio, let us say this is X. Okay. Okay. So what is the amount of X now? 50 by, okay, 50 by 10 inverse log. So inverse log equal to how much? Simply 5. So it is equal to 10 power 5. It is equal to 10 power 5, isn't it? So therefore, input signal power PSI equal to eta W into 10 power 5. What is eta value? The problem, it's been given as eta is 10 power minus 10. Okay. So it is simply equal to, and this is eta by 2. Noise power spectral density, okay, noise power spectral density GNF, okay, equal to eta by 2 equal to how much? 10 power minus 10. This means eta equal to 2 times of this. So it is equal to here 2 into 10 power minus 10 into how much is the bandwidth? W is the bandwidth of the signal, that is equal to 10 kilohertz. Okay, so 10 into 10 power. How much is this? So here it is 10 power 4, and it is 5, 10 power 9, and 10 power minus 10. So it is 2 times into 10 power minus 1. Okay, isn't it? That means 0.2 watts, isn't it? So 2 into 10 power minus 1. This is 0.2 watts. Now, in the problem, it is also given that attenuation loss, that is attenuation equal to, what do you mean attenuation? Output by input. That is the received power by transmitted power equal to, it is given in the problem as 50 dB. So look at here, the attenuation is given as 50 dB. Okay, so it is equal to 50 dB. That what is this attenuation? That's why I'm using minus. Attenuation means minus 50 dB. So it is equal to, if you convert this into number, it is equal to 10 power minus 5. Okay. Now, what do you mean received PR? Received power. Received power is nothing but the power at the input of the receiver, which is equal to PSI. Okay. So therefore, now PT equal to 10 power 5 into PR, that is 10 power 5 into PR is nothing but a PSI equal to 10 power 5 into, how much is this? 0.2. Okay. So how many watts now? It is 200 kilowatts. Okay. So when you multiply this 0.2 by 100, it is, sorry, 220, 20. It is 20 kilowatts. Okay. So 0.2 into 100 equal to 20, and kilo is there, 20 kilowatts. So this is the power required for a DSBSC and SSB system. Okay. If you want to transmit an analog signal, audio signal of 10 kilowatt, 10 kilohertz signal as a DSBC or SSB signal, we need this much power. Okay. And what about AM? In case of AM, the exact same procedure. For AM, what is the output SNR? Output SNR is simply equal to, okay, somebody raised the hand. Is that okay. Okay, tell me, Bhavani.
Sir, why you took minus 50 dB, sir, for attenuation?
Which one? Attenuation. Attenuation
Yes.
50 dB. Attenuation 50 dB means, attenuation means negative,
Okay.
That's why I'm using
Then,
minus.
okay, sir. Then while substituting, you took 10 power 5.
Not here, let me see. So it's minus 50. When you write this in the form of what is the number, dB converted into number, it will
Yes.
become 10 power minus 5.
Yes, sir. For in next step, you took 10 power 5.
Oh, I'm sorry. 10 power. Okay. See, PT, PT equal to, when you bring this 10 power minus 5 into the denominator, it becomes, when it comes to the numerator,
Okay.
10 power 5,
Okay, okay.
Okay, na? Okay, good.
Yeah.
Now, so now this is the power we need to have. If you're supposed to transmit an analog audio signal using DSBC or SSB, then the same case, what happens in case of AM? So in case of AM, we take output SNR. Output SNR is again, what is the equation of? Let me know what is the equation here. It is, this is a Ka square P sub m by 1 plus Ka square Pm into Psi divided by eta W. Okay. Now, here we are making an assumption, that is Ka square. We know what is Ka. Ka is the amplitude sensitivity. P sub m is the power of the message signal. And the product of this maximum value of this product is equal to 1 by 2. assume K square into PM equal to half. This is the maximum value, okay, at any case. Okay, so we can also prove this. Okay, so if this is the case, what about this SNR? Output SNR, it is 1 by 2 divided by 1 plus 1 by 2 into, and just I'm writing it as PSI by eta W. Okay, later I'll substitute the values, and this is simply equal to, so what happens, 2 to cancel, it's 1 by 3, that means how much? 1 by 3. So 1 by 3 PSI by eta W, isn't it? So now substitute the values. So what is the value of SNR? Same 50 dB. So 50 dB equal to 1 by 3 and PSI by eta W. Eta W. Now PSI equal to simply 3 into eta W into 50 dB is equal to how much? You can write 50 dB is equal to 10 power 5. Okay, so it is into 10 power 5. And after substituting, what happens? 3 into eta we know, 2 times of 10 power minus 10 into W. W is 10K, that is 10 into 10 power 3 into 10 power 5. So after substituting all these values, what happens? This is a 6, and here it is 10 power minus 1. It is equal to simply 0.6 watts. Okay. So once you have this same attenuation, so attenuation equal to received power by transmitted power, which is equal to 50 dB, and it equal to 10 power minus 5, sorry, minus, it's minus means 10 power minus 5, and therefore PT equal to 10 power 5 into it equal to PR. This is equal to 10 power 5 into PR is simply equal to this one. Okay, PR is simply equal to 0.6 watt. So it is 0.6 watts. Okay, how much is this? Simply, if you multiply 0.6 by 10, it becomes 6, and multiply by 10, 100, it is 60. So 60 kilowatts. Okay, so we can easily compare this one with the DSBC and SSB. In case of DSBC and SSB, how much is required? You see, 20 kilowatt is required. Okay, we need only 20 kilowatt power. Whereas in case of AM, how much power is required? 60 kilowatt power is required. Okay, so with respect to power, we can compare these are analog modulation schemes. Okay, from this normally which modulation scheme is said to be better? DSBC and SSB. Okay, so compared to all other, SSB is the best of all. Okay, how can you say that? Because it requires less power as well as less bandwidth, because bandwidth is only the bandwidth of a FM.